Hello everyone, this is part 2 video on past year NEET questions from the topic work energy power. Those who are looking at this video can take a look at the first part so that you will have continuity of questions. We'll start with a question that has come in the NEET paper 1 of 2016. The particle mass 10 grams moves along a circle of radius 6.4 centimeters with a constant tangential acceleration. Means what? The tangential velocity, of course the velocity of the particle in circular motion will be always along the tangential path, will be what? It will be changing with respect to time. Means this is a non-uniform circular motion. What is the magnitude of this acceleration if the kinetic energy of the particles becomes 8 into 10 power minus 4 joules by the end of the second revolution after the beginning of the motion? Beginning means what? Initial velocity is 0. So we have a particle starting from, let us say, A. It is completing one revolution and then the second revolution. By the end of second revolution, right? By the end of the second revolution, it is having a kinetic energy. What is the kinetic energy? 8 into 10 power minus 4 joules. So what is the kinetic energy formula? Half mv square, right? That is 8 in 10 power minus 4. Mass is what? 10 grams. Means we should take it in the SI system into 10 power minus 3. V square is equal to 8 in 10 power minus 4. So this is the 10 power minus 2. So V square will be 2 will go to the numerator, 10 power minus 2 will go to the denominator. So this is what? 16 into 10 power minus 2, that is our V square. So from here V will be equal to what? Root of, that is what? 4 into 10 power minus 1, that is 0.4. So initial velocity is 0. Final velocity is what? 0.4 meter per second after the 2 revolutions. Now if you look at the motion along the perimeter or the circumference, right? We cut the circle open. If we cut the circle open and then keep it like a straight line, what will be the total distance covered? 2 revolutions means, 1 revolution means it will be what? Perimeter 2 pi r. 2 revolutions means it would have covered a distance of 2 times the perimeter. So if you cut the circle open and keep it like a straight line, what is the total distance covered? 2 times of perimeter. Now if you think of it like, because the acceleration is along the tangential path always, right? This is like what? This is like a equivalent of the 1D motion when we cut the circle open and keep it. So what do we see? The acceleration is along the tangential path always, which means it will be along the straight line. We are supposed to find what is this? Initial velocity is 0. Final velocity is 0.4. Distance covered, which we now can equate it to what? The displacement. What is it? 2 times 2 pi r. So look at it. Displacement, yes, we can take it as what? 2 into 2 pi, 22 by 7 into r. R is what? 6.4 centimeters. Means 6.4 into 10 power minus 2. So 2 into 2 is 4. 4 into 2 is 88. 88 by 7 into 6.4 into 10 power minus 2. This is like what? 7 ones are 7 into 0.9 is 6.3. So approximately we can write it as what? 0.9. 88 into 0.9. 8 nines are 72. So there will be what? 79.2 into 10 power minus 2. 0.792 in terms of meter. We can approximate it as what? 0.8 also. So the displacement is what? 0.8. Now we have the initial velocity 0. We have the final velocity and we have the displacement. It's a case of uniform acceleration motion, the way we look at this in the 1D visualization. Then what it means? We have to find the acceleration, right? We can go for the equations of motion. What is the equation relating them? V square is equal to u square plus 2as, right? The equation relating these parameters is v square is equal to u square plus 2as, which means what? The final velocity square, 0.4 square is equal to what? U square is 0 square plus 2 times A into S is 0.8. So A we are looking for, this anyway 0. A we are looking for means we'll take the other things. So 0.4 square by 2 into 0.8, that is our A. 0.4 square means what? 0.16. 2 into 0.8 means 1.6, that is 0.1. So the acceleration value is what? 0.1. Since everything is the SI system of unit, it will be what? Having a unit of meter per second square. So what is the correct answer for this? Option C is the right answer. So here what we essentially did is, we have cut the circle and then we looked at the motion along the tangential path like a 1D motion. So whenever we have a question asked about this tangential path parameters, right, we'll always have to convert this into the equivalent of the 1D by cutting the circle and then try to solve the question. Next we have a question based on the power formula. A body of mass 1 kg begins to move under the action of a time dependent force. Means it is a variable force. What is the force? 2t into the I cap plus 3t square into the j cap. This is the time dependent force, where I cap and j cap are the unit vectors along the x axis, y axis. What power will be developed by the force at time t? So here a body of mass 1 kg begins to move. Begins to move means what? It is initially at rest. It is moving under the influence of the force, which means the velocity and the force. We'll have to look at what will be the relation between them. But here when we look at the force expression, right, what is the force expression? It is mass times acceleration, right? Mass is what? 1 kg. Means mass is 1 kg times acceleration is equal to what? Force. So numerically, acceleration function also will be what? Because 1 into A is what? This one, right? So acceleration function will be what? 2t into I cap plus 3t square into j cap. Divide by 1 means that is same, but unit will be meter per second square. That is the difference. This is the acceleration function. Acceleration can be written as what? The rate of change of velocity. Now velocity will have the corresponding components. Vx into the I plus Vy into the j. So derivative of velocity function means what? dvx by dt into I cap plus dvy by dt into j cap. So that is equal to what? 2ti plus 3t square j. Now what we need to do is we will have to equate the I components. That will give us dvx by dt is equal to what? 2t. dvx is equal to what? 2t dt. Now when we integrate this, right, the limits of time are 0 to t. X component of velocity, it is beginning, means initially will be 0. Finally let us call it as Vx. So here we have to conclude this by doing the integration. So what do we have? The x component of the velocity we will be able to get after time t by using this integration. So left hand side, what do we have? We have integral dvx, means what? It is like integral dx, that is what? Vx only, final limit is Vx minus initial limit is 0. Right hand side, integral 2t dt, that is t square, means t square minus 0 square. So Vx will be equal to what? T square. Now second term, dvy by dt, that is equal to 3t square, which means dvy is equal to 3t square into dt. This also we will have to integrate. 0 to t, 0 to vy. So left hand side is what? Vy. Right hand side is integral 3t square will be t cube. That is t cube. So Vx is t square, Vy is what? T cube. Now we will get the velocity function. So velocity function will be what? T square into I cap plus t cube into j cap. That is the velocity function. So we have the force function. Now we are getting the velocity function. What is the power? Power is, so what is the velocity function here? T square into I cap plus T cube into J cap. What is the power? Power will be equal to what? F dot V. Means we have to do the dot product. Dot product is what? Product of the I components 2T into T square, that is 2T cube, plus product of the J components 3T square into T cube, that is 3T power 5, plus product of the K components, there are no K components, means what is it? 2T cube plus 3T power 5, that is the power. Since everything is in the SI system of unit, it will be coming in terms of watt. So what is the correct answer for this? Option B, which is 2T cube plus 3T power 5. So here what did we do? By using the force function, since it is beginning, initial velocity is 0, we are able to get the velocity term by using the integration approach. From there we have used the F dot V formula for finding the power. Next we have a very standard question. This has come in the year 2016 paper 1. In fact, people remember these values like a standard result. What is the minimum velocity with which a body of mass m must enter vertical loop of radius r so that it can complete the loop? Entering means what? Generally, if you take the particle which is starting to move in a circular path, right? So this position, the bottommost point, right, is what you call as the entry point. It will go in the circular path and so this is the full circle. Now in the circular motion, right, there are two important points. One is the bottommost point, this is the vertical circular motion, and other is the topmost point. For the analysis of the vertical circular motion, right, these 2 points will be important. Now here what they are asking, the minimum velocity with which the body of mass m must enter the vertical loop so that it can complete the loop. So first, what do you mean by completing the loop? This is the center, right? The particle goes along the circular path as long as the rope is tight. Means what? The rope that is connecting the body to the center, if that is tight, means the particle is still in the circular path. If it comes out of circular path anywhere, means what? The rope becomes slack. So whenever the tension becomes 0, that is when the body comes out of the circular path. So this is what we need to keep in mind with regard to the condition for coming out of circular path. So as long as tension is having a value more than 0, right, the particle will never be able to come out. Now here they are asking what is the condition in terms of the velocity. What is the minimum velocity with which the body should enter? First we look at the tension. What will happen to the tension? See, it's a common observation. So when the body is at the bottom, the tension, we can feel that the tension in the rope will be higher. As the body is going up, the tension will keep decreasing. We can even see in terms of the representation of the actual quantities also. So look at it here, we will call the tension as T, imagine. The velocity here is V. So tension is acting towards the center of the circle, weight is downwards. For the particle to go in the circular path, it must have centripetal force, right? So net force towards center is what? T minus mg. T is towards center, mg is away. Net force towards center is what? mv square by r. So from here the T will be equal to what? mv square by r plus mg. That is the tension. Okay. Now we look at the topmost point. Let us say the velocity here is v dash and tension is t dash. Here we should note one thing. Tension will be acting into the rope, means downwards. Weight is also down. Both of them are towards center. So net force towards center means what? T dash plus mg here is equal to what? M into v dash square by r. Means T dash will be equal to what? M into v dash square by r minus mg. So here it is what? mv square by r plus mg. There it is what? M into v dash square by r minus mg. Now we'll have a doubt. It is not like we are subtracting mg from the same term. Here we are adding mg to mv square by r. There we are subtracting mg from m into v dash square by r. The question is which of them will be higher? Whether this V will be higher or V dash will be higher? We will see that V will be more than V dash. The value of V will be more than V dash, which means what? This tension will be what? Lesser. In fact, the tension as the particle goes in circular motion, right, it keeps decreasing. Tension will be the least value at the highest point. The particle will have the least tension force at the highest point. Now we will see what is the relation between the V and V dash. What is the relation between the V and V dash? From point 1, let's call it as point 1 and point 2. Other than gravity, there is only one more force acting, which is tension. Tension will be always radial, and displacement will be always along the tangential path wherever you take. So hence the work done by the tension force will be 0. Means tension does not do any work. As a result of it, right, so we'll just write down the relations here. T is equal to what? Mv square by r plus mg. T dash will be equal to what? M into v dash square by r minus mg. These are the two relations we have in terms of tension. Now what we'll do is we will erase this space so that we can use for doing the conservation of mechanical energy principle. Why? Because other than tension there is no other force, right? Gravity will be accounted in the potential energy term. So which means what? When we look at the kinetic energy plus potential energy of this body, that should remain constant. Means at the point 1, let us take it as what? The reference line. Potential energy will be 0. At the point 2, which is at how much height? R plus R 2R. Potential energy will be what? Mg into 2R. Here kinetic energy is what? Half m v square. Here kinetic energy is what? Half m v dash square. So relation is what? Initial kinetic energy plus potential energy 0 is equal to what? Final kinetic energy plus potential energy. M will get cancelled. Multiply both sides by 2. We'll get v square is equal to what? V dash square plus 4gr. V square is equal to what? V dash square plus 4gr. So we can see that V dash will be what? Lesser than V. Now the question is, they are asking what is the minimum value for this V. When V is minimum, V dash also will be minimum. When V is minimum, V dash also will be minimum. Look at this equation. From this equation, right, T dash plus mg is equal to what? M into V dash square by R. What is the minimum value for the V dash? See here, the mg we cannot change. The thing that can be changed is the tension. The particle can still remain in circular motion when the tension is what? More than 0. What is the limiting condition we are saying? If at the highest point, because everywhere else tension will be more than tension at the highest point. At the highest point, if we equate it, the tension to 0, if we equate the tension to 0, right, then we will get what is this limiting V dash. So what is it? V dash square will be equal to gr, which means the V dash value, corresponding V dash will be equal to what? Root gr. That is the minimum velocity at the highest point, which can keep the particle in circular motion. Means at that point the tension we are equating it to 0. Because anywhere below that highest point, tension will be what? Having a higher value means what? It will be still having some value. Topmost point we equate it to 0 means all the other points tension will be having some value. So that is the limiting condition. So while we use the limiting condition, we are getting V dash square is equal to what? G times R. Now we'll see this equation. Let us call it as equation 1. What is the relation we have? V square is equal to V dash square plus 4gr, right? So V dash square, we'll substitute gr. So gr plus 4gr, what is it? 5gr. So V square is what? 5gr. So V will be equal to what? Root 5gr. So this is the minimum velocity that we require at the bottommost point when it is entering the circular path, so that the body can complete the vertical circle. So here what is the condition, limiting condition? At the topmost point tension becoming 0, that is the limiting condition. Okay, so the correct answer for this is root 5gr. And if the particle is entering into the circular motion at the bottom point with this velocity, right? Then what we are going to have, look at it, we will be having at the topmost point tension becoming almost equal to 0, because ideally we should not say equal to 0. Why? Because then the rope becomes slack. We should say almost becoming equal to 0. And the velocity, so if we are entering the this is the minimum condition for completing the vertical circle. If we are entering it with a velocity of root 5 gr, by the time it goes to top, here the velocity will be what, root gr, and tension almost become equal to what, 0. But still at all other points below, tension will be higher than this, right? Means tension will be non-zero, means the particle will be able to just complete the vertical circle. Okay, so this is about the minimum velocity required at the bottom to complete the vertical circle. Next we have a question that has come in the year 2015. Two particles A and B move with constant velocities v1 bar and v2 bar. At the initial moment, their position vectors are r1 and r2. The condition for the particles A and B for their collision is, means somewhere we have this particle A and particle B. At the initial moment, their position vectors are given as what? Particle A, it is r1, so with respect to origin position vectors, and particle B, it is what, r. They are having velocities. Okay, so the velocity of particle A is v1 bar and velocity of particle B is v2 bar. They are actually what, constant velocities, means they will not change. Now we are asked what is the condition for the particles A and B for their collision. See, collision means what? They should actually meet. A and B should be colliding, means they should meet at a point. So to understand this a little bit more clearly, right, what we will try to do is we will try to convert this study of motion into relative motion phenomena. So we will try to observe the motion with respect to one of the particles. Let us say we make A as the observer. At that instant, right, initial, the position vector of B with respect to A, let us call it as r bar. What is the position vector of B with respect to A? It will be position vector of B minus position vector of A. So it will be, this is the r bar. Now we look at what is the velocity of B with respect to A. So what will be the velocity of B with respect to A? It will be, let us call it as the relative velocity. It will be what? Velocity of B minus velocity of A. Velocity of B is what? They are saying v2. Velocity of A is what? v1, right? So it will be what? v2 minus v1. Now the thing is, we need to understand what is this condition for collision to happen. Since we are making A as the observer, as per the relative motion concept, right, we visualize that A is not in motion, only the B is having the relative motion. For the collision to happen, the relative velocity vector, right, should be exactly in opposite direction to the position vector of B with respect to A. Then only, look at it. So it's like what? A is at rest. When we look at it in the relative motion concept, A will be like at rest. B will have to move and go and collide with A, which means the relative position vector r cap or r bar, right, and the relative velocity vector, they should be in opposite direction. Then only the B will be able to go and collide with A, which means what? The directions of r bar and v bar should be exactly opposite. Now how do we represent the relation in terms of directions? If say we talk about the unit vector in the direction of v bar as v cap and unit vector in the direction of r bar as r cap, then the relation we must have is what? V cap should be equal to minus r cap. V cap should be equal to minus r cap. Now we will try to understand what is this V cap value and r cap value. How do we get these V cap and r cap? So what is V cap? Unit vector along the direction of this V bar, right? Any direction, if you want to find the unit vector, means it will be what? The vector value divided by the modulus. So this is our V cap. And what will be R cap means vector divided by its modulus. Now the relation we are looking for is what? V cap must be equal to minus R cap, right? Which means what? V2 minus V1 by modulus of V2 minus V1 should be equal to minus of R2 minus R1 by modulus of R2 minus R1. If you look at minus means it will go inside, right? So it will become minus R2 plus R1. So what we'll have? V2 minus V1 by modulus of V2 minus V1 is equal to what? R1 minus R2 divided by modulus of, see, we can write it like, either modulus of R2 minus R1 or modulus of R1 minus R2, because anyway it is modulus. Why are we making these changes? Because in the option they have given it like that. Modulus of R1 minus R2 is same as modulus of R2 minus R1. So look at it. What is the correct answer? Option C. R1 minus R2 by modulus of R1 minus R2 should be same as what? V2 minus V1 by modulus of V2 minus V1. So the relative position vector and relative velocity vector, they should be in the opposite directions. That is the condition for the meeting to happen or the collision to happen. Okay. The correct answer is option C. We'll go to the next question. Another question, 2015. The heart of a man pumps 5 liters of blood through the arteries per minute. Means 5 liters, right? Which is what? 5 into 10 power minus 3 meter cube. This much volume is pumped in 1 minute, means what? 60 seconds. So the volume rate, the volume at which the blood is pumped is what? The amount in terms of volume divided by the time, right? Which is what? 5 into 10 power minus 3 meter cube divided by 60 seconds. This is the volume rate of the pumping of the blood. This is done at a pressure of 150 millimeter of mercury. Means if you have the artery like this, right? We are pumping it with a pressure of how much? 150 millimeter of mercury. If you want to convert this into the SI system, means 150 divided by 760, because 760 millimeter of mercury is 1 atm. If you divide 150 by 760, means that will get the pressure in terms of atms. We have to multiply this with what? 1.01 into 10 power 5. That will give the pressure in terms of pascals. Because we are trying to have everything in the SI system, right? We are converting this mercury pressure into the pascal. For that only they have given this. If the density of the mercury is 13.6 in 10 power 3 kg per meter cube and G is 10 meter per second square. So these values are given to convert the pressure which is in millimeter of mercury into the SI system. But already we know the conversion factor, right? 760 millimeter of mercury means that is what? 1 atm. So if we divide the given millimeter of mercury pressure by 760, means that will get the value in terms of atm. 1 atm is what? 1.01 in 10 power 5 pascals, right? So we multiply by that, we will get the final pressure in terms of pascals. So this is the pressure. Now we need to find the power, right? See here we are pumping the blood at a particular pressure, and there will be a velocity for the blood flow. Pressure multiplied by the area of cross section, right? That will give us what? The force acting over here. This multiplied by the velocity, that will give us what? The power. Because force and velocity are in the same direction, right? Power will be equal to what? Force into velocity, if they are in the same direction. Otherwise we have to use that power is equal to what? F dot V. We have seen previously some questions are like that. Here pressure is known to us, velocity is not known to us, area is also not known to us. But what is this area into velocity? Area multiplied by the velocity, right, will give us the volume flow rate. This is something that we will see even in the properties of fluids. The area of cross section multiplied by velocity will give us what? What is the total volume that is covered in a given time. So we can look at in terms of the units also. This is what meter square, this is what meter per second. It will give us what meter cube per second, which is the volume flow rate. So power is nothing but pressure into the volume rate. Now it's very straightforward. What is it? Pressure is 150 by 760 into 1.01 into 10 power 5. Volume rate is what? 5 into 10 power minus 3 by 60. Now we'll have to just simplify this and we'll be able to get the answer. So here maybe if needed, right, we can do some approximations here and there so that we'll be able to arrive at the closer option in a lesser time. So look at this carefully. This is what 10 power 5, 10 power minus 3. 10 power 2 will remain. 6s, 76s. The 10 power 2 also will get cancelled. So what do we have here? 150 into 5, that is 750 into 1.01 divided by, this is what, 76 into 6. So maybe numerator, right, we can just take it like what, 750 into 1.01 means we can take it as approximately 750 only. Denominator is what, 6 6 are 36, 6 7s are 42, so it will be 456. So 750 by 456, if you try to do the division, right, we should get the value approximately 1.7. Since everything we have taken in the SI system of unit, right, the power must be coming in terms of the SI unit, which is the watt. So the answer is what? 1.7 watt. So here we must remember this. This is a very standard question. So with regard to the pumping of the blood, where we will pump the blood with a particular pressure, pressure into area will give us the force, multiplied by velocity will be the power. So thereby the power will be equal to what? Pressure into volume rate. Next we have a question that has come in the year 2015. A ball is thrown vertically downwards from a height of 20 meters with an initial velocity v0. Means from a height of 20 meters we are throwing it down with a velocity v0. It collides with the ground, loses 50% of its energy in the collision. Means what? It is losing half of the energy. And rebounds to the same height. Means after losing half the energy, it is able to rebound to the same height. Means when it comes to this point, right, so this is like our initial, this is like our final. When it is coming to the final point, it is only having potential energy, there is no kinetic energy. But initially at the time of projection, right, when you are throwing it down, it has got potential energy because it is the height of 20 meters from the reference. And also it is having a velocity, it has got kinetic energy. So the relation is when it is losing 50% of the energy in the collision. Look at this. What is the energy at position 1? M into G into 20 plus half M into V0 square. Correct. Now half of this is basically the energy possessed by the particle when it is coming to position 2, right, which is what? M into G into 20. So half of the initial energy is what the body will possess, because it is after collision it is coming to that height, which means what? If you take the 2 to the right side, it will go to the numerator, right? So what we have is mg into 20 plus half m v0 square is equal to what? Mg into 40. So m will get cancelled. If you bring this is g into 20, so we will be having what? If you bring it to the right side, means it will become minus g into 20, right? So it will be net we will have what? G into 20 on the right side. What we have is half v0 square will be equal to what? G into 20. which means V naught square is equal to what? G into 40. We'll take G as 10, right? So 10 into 40 means what? That is 400. That is V naught square. Means V naught will be equal to what? Square root of 400. That will be 20. Since everything is in the SI system of unit, the V naught value will be what? In terms of the SI unit, meter per second. So just we are using the relation between the energy they have given. So they are saying, it is losing half the total energy, means the initial energy half times of it will be the remaining energy. Next, we have a question that has come in the year 2015. This is an interesting question. I'll tell you why. On a frictionless surface, a block of mass m moving with a speed v collides elastically with another block of mass m. Means what? This mass m, which is initially at rest. This is at rest. This moving block is colliding. It's coming with a velocity v. After the collision, the first block moves at an angle of theta to its initial direction and has a speed of v by 3. Means the first block is moving a direction making an angle theta. What is the speed? V by 3. The second block's speed after the collision is. I'll tell you why I said this is an interesting question. See, here they are clearly mentioning what? This is an elastic collision. Elastic collision means what? The kinetic energy of the particles before the collision will be equal to what? Kinetic energy of the particles after the collision. So before the collision, what is the total kinetic energy? Only the first one is, let us even number them, first and second. The second might go in some direction. Let us not even bother about which direction it goes after the collision. With some velocity, we'll call it as v dash. Okay. Now before the collision, what is the kinetic energy? Means half m into v square. Only one of them is moving. Block 2 is not moving, right? Finally, what is the total kinetic energy? We have to add kinetic energy of the this is 1 and this is 2. We have to add both of them, right? So for the block 1, what is the kinetic energy? Half into m into v by 3 the square. Block 2, what is the kinetic energy? Half into m into v dash the square. So from here only we will be able to find out what is the second block's speed. So I said why the interesting part of this question is we should not get carried away by the fact that they are mentioning some angle here and try to probe into that dimension. Yes, for every collision we can apply conservation of momentum, but here we will be able to answer the question just purely based on the conservation of energy rate or conservation of kinetic energy, because it's an elastic collision. So look at this, we can cancel half m on both sides. We'll have what? V square is equal to, this is v square by 9 plus v dash square. V square by 9 will go to the LHS. V square minus v square by 9, that is 8 v square by 9, that is v dash square. We'll take a root on both sides, means what we'll get? V dash value will be equal to 2 root 2 v by 3, which is our option C. So the moment we realize that only one of the velocity is missing, initial velocity of both the particles is known to us, final velocity of one particle is known to us, only the other particle final velocity is not known to us, right? And they are clearly mentioning this is an elastic collision, so we can go for the conservation of kinetic energy of the particles. Next we have a question that has come in the 2015 cancelled paper. This is a very standard question. In fact, we have similar question in another year also, but in that question they have asked for the velocity function. In this case they are asking for the force function. So we'll see the approach will be similar in both the cases. A particle mass m is driven by a machine that delivers constant power k watt. So here the mass m is driven by a machine which is delivering the constant power. Power is constant. If the particle is starting from rest, means initial velocity is 0, and it will move in the direction of the force. So whatever the force that is being applied, it will move in the direction of the force, which means force and velocity are in the same direction. Now we need to find the force on the particle at time t. So here this question, right, can be solved either by using the integration method or by using the normal approach. So first we'll start with the normal approach where we will not use the integration technique. Then I'll show you the integration approach also. So here we need to find the force acting on the particle at time t. Means we'll consider this time interval between 0 to t. Power is constant, right? So what is the work done? The constant power k into t, right? Now work done on this particle will result in what? It will result in here there is no mention about the potential energy. So work done on the particle will be equal to what? Change in kinetic energy, which means final kinetic energy is what? Half mv square. V is the velocity at time t. V is what? The velocity at time t. Minus initial kinetic energy 0. Which means work done kt is equal to what? Half m v square. So we'll bring 2 will go to the numerator and m will come to the denominator. That is v square, which means what? V is equal to root 2 kt by m. In fact, in the other question, like I said, right, they have exactly asked us what is this velocity. That's it. We would have got the answer for the other question. But here they are asking us what? Force, right? So how do we relate power? Power is equal to what? Force multiplied by the velocity at the instant, right? Which means what? The F will be equal to K divided by V. So from here K is equal to F into V means K divided by V is equal to what? F. That is what we can. K divided by V is what? Root 2 kt by m. So K into root m divided by root 2t into root k. So this will get cancelled. So what do we have? We will finally have the numerator 1 root k will remain. So what is it? Root mk. Denominator will have a 2 and also there is a root t in the denominator. So option wise, right, they have expressed this root t in the denominator as t power minus half, because if you have root t in the denominator, right, we can express it as what? T to the power of minus half. So answer is what? Option C. So this is the method that we will use where we are not applying that integration technique. Now we can also solve this question by using the integration approach. So here what did we do? We have used the work energy theorem condition. Work done by the force is equal to what? Change in kinetic energy, because there is no mention about the potential energy. From there we are able to get what is the velocity function, and once we know velocity function means F into V is equal to K, right? We will get the F value. That's it. Now the second method where we are going to use the integration. So here if you look at the power is what? F into V, right? Force is mass times acceleration. Acceleration is dv by dt. Now when we rearrange, let us bring the dt to the left side. K dt is equal to m times v dv. This expression, the integration limits for the velocity will be 0 to v. Time limits will be 0 to t. So this will give us what is the velocity function if we integrate this expression. So look at this, left hand side is what? K into integral dt will be t. So final limit minus initial limit. This is what? M into m is a constant, comes out. Integral v dv is like what? Integral x dx. What is integral x dx? X square by 2 means v square by 2 minus 0 square by 2. This is kt is equal to what? M into v square by 2. So you can check it from here. We are going to get the same answer. 2 kt by m is equal to v square means v will be equal to what? Root 2 kt by m. Once we get the v means we will use the same formula. F is equal to what? K by v. So both the methods we are going to get the same answer. Either we use the work energy theorem method or the integration method. So first we will get the velocity and then we will use the relation. Power is equal to what? F into v relation. Then we will get what is the force function. Next we have another question from the 2015 cancel paper. Two particles of masses m1 and m2 move with the initial velocities u1 and u2. Their initial velocities are u1 and u2. On collision, one of the particle get excited to a high energy level after absorbing energy E. Means one of them is absorbing energy E. If the final velocities of the particles are v1 and v2, then we must have, see, what is the initial kinetic energy? Half m1 u1 square plus half m2 u2 square. What is the final kinetic energy? Half m1 v1 square plus half m2 v2 square. Now let us say the initial kinetic energy is some 60 joules. Final kinetic energy is some 45 joules. The remaining 15 joules is absorbed by the particle to get excited, right? One of the particles is getting excited by absorbing energy. So that is the 15 joule, which means what is the relation we should have? The total initial kinetic energy, half m1 u1 square plus half m2 u2 square should be equal to what? Half m1 v1 square plus half m2 v2 square plus that energy E absorbed. But if you look at these options, right? Look at this option. What is the corresponding option? We have option A. They have just brought this E to the left side. When we bring it to the left side, it will be what? Minus. So the one that they are expressing is what? Half m1 u1 square plus half m2 u2 square minus E. This is like what? 60 minus 15. That is equal to our 45. Half m1 v1 square plus half m2 v2 square. I took the numbers and explained so that we will be able to clearly understand this. So what is the correct answer? Initial kinetic energy minus the energy absorbed for excitation will be equal to what? Remaining will be the final kinetic energy of particles. Next we have a question from 2015 cancelled paper again. This is based on the spring. Two similar springs P and Q have spring constants Kp and Kq such that Kp is more than Kq. Okay. They are stretched by first same amount in the case A. Means what? Let's look at it. We have spring P. It is stretched by amount X. Spring Q is also stretched by the same amount X. Which means in this case, right, what is the spring energy or the work done by the spring is what? Half Kp into x square. Here what is it? Half Kq into x square. Since Kp is more than Kq, right? Since Kp is more than Kq, what do we have? Wp will be more than Wq. So here what they are asking, they are stretched first by the same amount, that is the case A. So here we are discussing what? Case A. And then by the same force, which is the case B. The work done by the springs Wp and Wq are related as, in case of case A and case B, what is the relation? See, here itself we will be able to conclude the answer. Why? Because case A we should have Wp more than Wq, right? In the options given to us, only one of them is actually matching it. What is it? Option A. Only one of them is matching our answer, which is option A. Now look at the second case. Second case, they are stretched by applying the same force. They are stretched by applying the same force. So if they are stretched by applying the same force, let us say that corresponding force is F. Here the force will be balanced by the elongation of the spring, right? Which means what? Here let us say the elongation is xp. Here let us say the elongation is xq. Force will be equal to what? Kp into xp. So from here F by Kp is equal to xp. Here force will be equal to what? Kq into xq. So from here also F by Kq is what? Xq. Now again we look at the work. Half Kp into xp square, right? Which is what? Half into Kp into, in place of xp what will substitute? Which is what? F square by 2 Kp. Now similar expression, right? Wq will be what? It will be F square by 2 Kq. So here what do we see? The relation is what? inversely related to the spring constant, which means Kp is higher, right? Which means what? Wp, here denominator is higher, so value will be lesser. Wp will be lesser than Wq. The other way to say it is what? Wq is more than Wp. So in the first case, the one that we discussed before, right, we had Wp more than Wq. Second case, the case B that we are discussing here, when we have the same force that is causing the extension, Wq will be more than Wp. Okay, so this is about this part video, and we'll see in the next part.